What's up everyone, and welcome to another Rust electrical tutorial. I'm Nicish, and today we're going to be doing another industrial build, this time the fully automated drop and go wood furnace smelting. Now I just posted a video recently using this exact same idea, except for the electric furnace. I'll post a link if you'd like to check that out. Over here I have a power bank set up to power everything. I'll provide a link for this as well if you're interested in knowing how and why I use this. The total active usage of this system here on the battery is 28, so really not that bad. I'm sending 28 out of this branch out here. I have 71 left over, so relatively cheap considering what we're doing. So before we get started, I'm just going to do a demonstration of how this thing works. I'm just going to do, let's see, 20 metal ore, we'll do 20 sulfur, and 2 high quality since they take longer. And I'm just going to dump them into this box here, and it's going to automatically pull into the system. It's going to ignite the furnaces on its own. It's going to smelt everything down and transfer, and it's going to be, all the products are going to be transported out here into this box up there. And then when it's finished, once it's finished, this conveyor here, which pulls in the wood, is going to get turned off momentarily to allow these to burn down the whatever wood they have left. And then so once they run out, that's what will shut them down. And then this will turn back on after it's shut down so that it can repopulate and prime it with 5 pieces of wood for the next time you're ready. So it's fully automated, no buttons, no switches, no on and off. You just drop it and go. So we're gonna see here, let's see, we got 3 left there, 2 left there, none in there. So this one's just pulling out charcoal, this is pulling out smelted items, and as soon as it's done here in a second, it's going to shut off that top right conveyor to cut the wood supply. There it went. And now these are going to burn down what they have left, and then they will extinguish, and then that thing will auto-populate. There we go. It's back on. And if you give it a moment, it reprimes these each with 5, and it's ready to go. So that's it. All right, so let's go ahead and start with the industrial parts of this. I think that's a good place to begin. And I think as far as, you know, the build on this part, it's actually not too bad. So we'll just go ahead and take a look at this. So I obviously have the 3 furnaces. Because the furnaces aren't powered, you could just plop this the adapter onto even a large furnace. So it doesn't really change. It doesn't change any of the electrical components if you decide to put this on on the large furnace, or maybe a couple of these on the large furnace. So just a little tip there. So I've got the 3 furnaces here. Each furnace, you know, there's a ore inlet. An ore inlet conveyor here, and then there's a wood inlet conveyor here. So they're of course attached to these boxes. The wood one here is just running over to this here. Now you can rotate these with R before you place them. So I've actually placed this upside down. That's how I did that. That's why the output on this one is facing here, and the output of this one is opposite facing here. You can do them upside down so that you can do things like this. But anyway, the wood supply box here is running to the input on this conveyor here. Its output is running to this combiner up here, and of course that combiner is attached to a splitter, so we can split it back up into these 3. So then you have on the ore side, this is the ore box, this is the drop and go box. Its output on its storage adapter is running to the input on this conveyor here. Its output is also running to this combiner here. The combiner is just, you know, the output of the combiner is going to the input on this splitter right here. The splitter's outputs, the output, you know, the output 1, I guess, is running to the input on this one. It doesn't really matter which way you did it. I just I did it this way so it would look good, but the 2 is running to this one's in, and this input here is running to the, you know, the out of this one is running to the input here. So basically it's just a splitter running to the inputs of these 3 items, these 3 storage adapters. Their outputs, the 3 outputs of those storage adapters, are running to this combiner down here. Its output is then running to another splitter to split it back out so that I can take out selectively. I have to, for reasons we'll talk about later, I need to separate the charcoal from the ore, because this conveyor here is the one that actually signals this to turn off once it stops pulling out smelted items. And so this is required so that, you know, the system can shut down. We'll talk about that in the electrical portion of this, but that's pretty much it. All you're doing is taking the 2 boxes here, the wood and the ore. Each one is running, so that each one's running to its respective conveyor. The ore conveyor is set up to filter for metal ore, sulfur ore, and high quality. And all you do there is just search for whatever it is you're trying to find. click on it and select add. So it's only gonna try and find those items. So you would filter this to whatever it is you want it to smelt. The wood conveyor only is going for wood. It has a max setting of 5. So whereas over here I set these to nothing, because I wanted whatever, if it's in the box, I want it to grab it. I don't want it to care. But the wood conveyor, I do need it to care, because I want to keep a maximum of 5 pieces of wood at any given time. So instead of when before this we would load these up with a stack of wood, now I just want it to maintain anything above 1. I don't care how much is in there, as long as it doesn't run out. 5 seems to be the magic number based on the sort of the timing of these conveyors. So I have this set to a max of 5. So this will stop pushing wood into these furnaces once this reaches 5. So anytime, and this is how we keep these things going, and it also helps us to extinguish them when we're done. So the outputs of these, again, are coming into this combiner here, into this splitter. This one is set to pull charcoal, no min, no max, just whatever it can see. This one is set to filter out just the products here. So we have metal frags, sulfur, and high quality metal. Again, no min, no max. We just want this to pull out anything that it sees. And that's pretty much it. The outputs of these are just running. So this output here is running to this input on this storage adapter. This one, the charcoal one, is running its output. Again, I put this in upside down. Again, you'll notice the inputs here and the outputs here. It's because I flipped it upside down. You can tell by the position of these lights. And I ran that output to the other storage adapter on the same box. At this point, you could then from here start or even just out here even, but at least from here you could start a sorting system if you were interested in doing that. So what we're going to do next is we're going to start into the wiring. Looks a little daunting, but it's not too bad. We're going to break it up into pieces. Okay, so this bottom part here is just the power distribution block. That's all this is doing. This is what, if you come over here, this is what this output here, this green output here, is running to the input on the bottom of this branch here. So that's that 28 that I told you that I was sending over from the battery. That's arriving here. And then all I'm doing is I'm just daisy chaining power out to power in, power out to power in, power out to power in to each of these branches, so that I can send off the things that I need for each particular circuit. We're going to go ahead and start with the igniter here. We have on the OR industrial conveyor the filter pass. So we're not going to use the filter fail. We're going to ignore that. Don't hook anything up here. The filter pass, we're going to run that to the either side of this AND switch. So we've got the filter pass running to, in my case, input B of this AND switch. This power out of this AND switch is running to the toggle on of this timer, which is set to 1, because we want to use it like a switch. And the whole reason we want to do that is if I didn't have this timer, if I didn't just initiate a quick 1-second timer, this igniter over here is going to run the whole time that filter pass is on. This requires, I think, at least 2, so you'd have to send this to an AND switch anyway, because we need more than the 1 that comes out of here to power this thing. So that's why we're using an AND switch in its root. The root reason here is that this igniter needs more juice than this filter pass can put out. So what we do is we run what we need to the igniter, which in this case is, if you look here, is 2, because it's like 3 here, but 1 powers this. 2 comes out of here. We need 2 to run this. And so what we want to do is when this filter pass goes off, it's going to complete the 2 required. So right now we have 1 volt coming out of here, and so that is going to power. We see we've got the green light on the left side. That's going to power the AND switch for us. And the input B is once that filter pass. So basically that filter pass will send out something when there's something in here to pass. That's how we're turning it on, is that this thing's looking for items in this box. As soon as I put items in this box, it's going to send that filter pass, saying, hey, I'm passing stuff, I found stuff, and that's going to complete this requirement here of the input A and input B both receiving power. And so since this is going to send 1, and then this is going to send 1 here, it's going to then pass just 1, doesn't matter which one it is, so that we get a toggle on of this timer, which this output here, the branch out here, is set to 3. This one only needs to pass 1, so we're only receiving 5 here, 1 for the branch, 3 for the branch out and 1 left over to run to here. And so this 3 is going to arrive here. This is going to use one of those 3. We have 2 left, which comes out of here. So once this activates, it's going to send 2 out of the top of this timer that are going to fire this igniter for 1 second, and that's all it does. So it seems a little complicated, but all it really is doing is running the igniter for 1 second and just not letting it stay on. You could ignore this timer if you don't care about the igniter just running, but that bothered me, so I didn't do that. So that's all that is. So to power this little block, this little igniter block, again, you need this 1 branch, 5 arriving at that branch. So if you follow this power line here down to its branch, we have in our power block, this branch out is set to 5 because I need 5 here. 1 to power this, I have 4 left over. 3 is going to come out of here, 1's going to come out of here, and that's all you need. And so just make sure that you set this timer to 1 second because we're using this as a button and not a timer. So that's how we're turning it on. As far as the other parts of the block here, we might as well just power up, or go through where these power are going. This branch out here is running to the conveyor itself, and you'll notice that it is set to, where is it? Right there. It is set to 4. And so the reason that we have this set to 4 is that the conveyors are daisy chained. They have a input here, power input, and then they have a pass through on the other side. So what you can do is you can just send, so I've got 4 arriving to this conveyor. It's going to use 1. It's got 3 left over, so it's going to send it's going to send that along, and it's going to send it to the input. I've got that pass through of this conveyor running to the power in. This one's upside down, remember that, over here. So I've got 3 arriving here. It's going to use 1. I'm going to send the pass through of this conveyor out to the next conveyor over here. So now its power in is receiving power from the conveyor up there, and then its pass through, now it has 1 left to pass right here. And so this pass through is now running to the power in of this conveyor. So I'm just daisy chaining. I'm sending 4 out. And I'm just daisy chaining 1 to 2, 2 to 3, 3 to 4. Simple as that. Easiest way to power these things. So that is the conveyor power. This right here, this branch out here is running to a timer back here. The reason I'm using timers, this one's also set to 1 second, is that I need buttons to kind of push themselves. And you can use a timer as a button by sending a signal to run the timer, especially if you set it to 1 second. It's just going to send one output volt here, and this timer here is connected to the turn off of this. So a lot of this gets a little funky here. So we're going to cover that more here in a second. But this power out here is just 2, and it's powering this timer over here. This power out over here is 11. This is the largest output. We've covered all these. This is that timer over there. This one is the 4 conveyors, or no, I'm sorry. This one is the igniter circuit. This one is the 4 conveyors, 1, 2, 3, 4. And then this one here is this is a delay circuit. I've actually made a video about this. I'll provide a link if you want to know more about it, but we're going to cover it right here. This is a delay circuit with an extra branch on the end. And this is how I am turning off, I'm cutting off power to the wood conveyor so that these things run out of wood and extinguish, and then it has a delay timer where then it comes back on and turns this thing back on after they've extinguished, so that it can then prime these with 5 pieces of wood again for the next time that you drop something in that box. And so I'm just going to go over how this works, and then we can just look at the wires, and we'll make sure that it's clear as to where things are going. But this is a delay, and so I've got a branch here. The delay circuit's actually these 2 branches, this timer, this blocker, this timer, and now I've added from the output of this timer an extra branch because I needed that over there. But just for the timer itself, you have the first branch out here. So the actual main power to this circuit is set to, the branch out set to 11. This first branch has a branch out of 2, and the rest is going out. The remaining 8 is going to run out here. So this one is set to the input on this this timer here. Again, this timer is also set to 1 second. And then this, so 2 coming out of here to this timer. The power out of this is running to the power in on this branch here, and then its 2 outputs are running over here. Now, it's very important that these be in the right order in this particular build. That's not always the case with these, but in this particular build, the branch out here has to run to the blocker. So you have to run the branch out in its default 2, just like this one's in its default 2. It's going to run the 2 to this blocker here, which uses 1, passes 1 to here. And then the power out has 5, so that's what's left over. We have 8 arriving, 7, this uses 2, 6, 4, 7, 6, 5, so we have 5 left. So this 5 out here, this power out, the 5 must go to this timer here. And this timer you're going to set to 6 seconds, because this is the delay while these run out of wood before it swaps back over to this timer, which acts as a button and turns the wood conveyor back on to prime these with the 5 based on its filter settings. And so that's pretty much it. And so once you have these set up and run to here, this timer again is set to 1 second. This timer is set to 6 seconds. This branch is going to be left in its default configuration, so you're going to leave it with the 2. It doesn't actually matter that this is arrived, so you have to send the branch out over to here. It is wasting a volt, but I mean, it doesn't really matter. And then this output here, the power out of this is going to, okay, so timer out, I should have said that, timer out to the power in on this branch here. Its branch out is running to the block pass through on the blocker. The blocker output is running to the toggle on of this timer, and now the power out of this final branch over here is going to run all the way over to this timer over here that we talked about earlier to its toggle on. So the power out of this is going to run to the toggle on of this timer over here. Its output, the output of this timer here, is going to run to over to here to the turn off. That's running to the turn off right there. You can see it underneath there. So don't confuse these. They are both hooked up. This is the turn off. The turn on of this conveyor is the power out of the output of this first timer here. So this timer is the one that turns it back on after a 6-second delay. So this timer is running to the turn on this conveyor over here. The filter pass and filter fail are not used on this particular conveyor. So that's the delay circuit. The final thing that I have to do is I have to from this conveyor down here. This is the conveyor that you're running your outputs from, the sulfur, the frags, the sulfur, and the high qual. Its filter fail, so not the pass filter, the filter fail specifically, has to run to this AND switch. Now, I tried running the filter fail, or the filter fail over directly to this input on the toggle on that I wanted, but it turns out that these things, as they cycle looking for stuff, it interprets that as a power fluctuation, and so it turns this into a clock circuit on accident. So you can't run the filter fail of this straight into the toggle on like you probably want to. You have to use an AND switch in the middle of it to keep a solid power, so it doesn't keep cycling the power here. So what I did was I took a power out of this final one, and that's why that value I set over there reflects that I want 2 to be in the end here. I ran that to one side of this AND switch. It doesn't matter which side. I just need 2 volts specifically. It has to be at least 2 or more. Has to run to one of these inputs. The other input A or B, whatever, is going to run to the conveyor. And the reason that this has to be 2 volts, the filter fail from that conveyor, is that the conveyor will the way an AND switch works is that it passes the greater of 2. It requires both power, and it'll pass the greater of the 2 that it receives. So since the conveyor is sending 1 and the branch is sending 2, it's going to pass the 2 because the conveyor is actually powering this thing, so you get the full 2 coming out and arriving here, and it's not cycling when this thing is hunting for stuff. So this is a way around that problem by using this AND switch. So it's just a powered sort of, when this thing is passing stuff, the filter fail will turn off, and then you'll lose this power, which means you won't have both these ons, which it won't pass anything, so it works perfectly. So that is pretty much it. It seems kind of like a lot, but you can think of it as the power distribution area here. We have the timer that turns it on and off here, and we have the igniter system set up over here. So the actual outputs we've covered, the electricity we've covered. So now we can kind of just play with it, and I'll show you why it's working the way it's working. And so what's going to happen is I'm going to put the ore in, and so this conveyor is going to start pulling ore. When it does that, it's going to send out a reference volt from this filter pass here, because it's passing stuff. Right now it's 0 because there's nothing in there. So it's going to send out a volt, again, unused filter fail on this one. And it's going to send that to this AND switch, which is going to provide the other side of the power. Right now we have power to A and not B, so we'll get B. It'll pass a volt. It'll turn on this timer for 1 second, which has 3 coming to it, so that it has 1 to power and 2 left over of the required 2, and it'll run this thing for 1 second, igniting all your stuff. That's all that little system is doing. Once that receives that, it's going to start passing stuff into these and splitting them up into these furnaces. And as long as it keeps smelting, this thing right here, this conveyor here is going to make sure, because again, I've got this set to 5. So in the target container, in this case, the target container is these furnaces. So it's going to try and maintain 5, and so it'll never get below 1, which was what I had to avoid. And so it'll just keep 5 in here, so you don't waste a lot of wood. You know, it's very, very efficient actually, as long as you keep this wood at 5. And so as it's doing that, it's going to be pushing wood in, and this stuff is smelting, and it's going to be, this filter is going to be pulling out metal frag, sulfur, and high qual. And as it's doing that, it's not going to send a filter fail, so this will be 0. The filter pass will have 1, but we're not using it. And so this will not be passing power, which means this thing is not activated. Once this gets a signal in the filter fail, it's going to send that signal like it's doing right now, which is going to activate this AND switch, which is going to send power to this timer here, and this timer is going to run for 6 seconds. And while doing that, it sends out a voltage, right? It's going to pass. It's got 5, so it's going to pass 4. It's going to pass voltage for 6 seconds, which is this here is connected to the turn off, which is going to turn this off for 6 seconds. That 6 seconds allows these to burn down what's left of the wood, and then extinguish. And so once that 6 seconds is over on this timer is going to run for 1 second, because this is a delay circuit, right? This timer is going to run for 1 second, which is going to turn this back on, which is then going to, again, repopulate 5, which is how it primes these to finish. So we'll just do one more demonstration, and I think I'll just do, let's see, we'll do 10. We'll do a smaller amount this time. But we'll do one more demonstration, and now you can try and watch and see as these systems are running to each one. So if I come over here to the ore box, you know, again, this is my wood supply. I'm going to just pop these in there. This one has detected them, and it has pulled them in. So now it's already pulling them in. It's already smelting. This one's got the high qual. This one's got none. So I didn't put enough in there. It pulled them in too fast. And that's okay. We're just going to make some charcoal out of this one. This one's going to pull these out as it finds them. It's going to be placing everything into here. And then this one here is going to be pulling all the charcoal out. Note that we didn't use any of the outputs on this, because all this is doing is pulling charcoal out, because we want the reference signal, the filter fail, which is currently 0. You'll notice that the AND switch is not lit up on both sides, so we're not passing power to this input here. But as soon as this thing runs out, it's going to send this signal over to here, which is going to initiate this for 6 seconds, which is going to turn that off for 6 seconds, which allows these to extinguish because they run out of wood. Once this is done running, it's going to then delay circuit allow this to run for 1 second, which is going to turn everything back on and allow these things to repopulate. So there it went. You got the signal. It's running for 6 seconds. That one's off over there. These things are going to extinguish. You'll see them go out. And then as soon as it turns that back on, it repopulates the 5. And there you go. We're ready for the next one. So I hope that was clear, folks. It's kind of hard to describe these things in such detail. But if you have any questions, obviously, please let me know. So that pretty much does it. If you have any questions or comments, you can leave them below. Otherwise, you can get me on my Discord. See you later.